Okay, so I'm going to be discussing two questions. Does a muscle meat carnivore diet provide enough calcium? And does a carnivore diet induce low-grade metabolic acidosis? So people in the carnivore community like Barkay have been saying that there's perfectly sufficient calcium in muscle meat. However, I'm arguing that there is not based on metabolic ward studies. So the first metabolic ward study is the Belleview carnivore study that was from 1928. It took place in the Bellevue Hospital of New York City, and it was the two Arctic explorers, Stephenson and Anderson. So Stephenson he had explored the Canadian and Alaskan Arctic for 11 years. About 9 of those, he was mostly on a carnivore diet, and Anderson explored the Canadian Arctic with Stephenson for 5 years, and for about 1 of those years, he was mostly carnivore. So both of these individuals had previously been on a carnivore diet and actually enjoyed it, and they lived with the Inuit and ate what the Inuit ate. So they decided, basically a decade after their explorations, to do a 1-year carnivore study. So it was a 3 to 4 month metabolic ward study. 2 of those 3 months was on carnivore, and they were on a carnivore diet for a total of 367 days. For Stephenson, and Anderson was 375 days. I might have got that mixed up. I'll cover the actual days in a second here. Let me just quickly look and just double check. So it was Stephenson, that completed 375 days, and Anderson was 367. So it was, in total, they were on a carnivore diet for actually slightly over 12 months. And what they ate was the meat, the associated fat, and some organs. So they would consume like liver, kidney, brain, a little bit of bone, some fish bone, and gnawing on some short rib bones. Primarily, the meats were beef, lamb, veal, pork, and chicken, and they consumed muscle meat, liver, brain, bone marrow, bacon, and fat. When Stephenson was on lecture, occasionally he would eat a few eggs and a little bit of butter when meat was not obtainable. Okay, so for Stephenson, he was on, at the start of February 13th, 1928, they put him on a 3-week mixed diet. And then he was admitted to the metabolic ward in February 26th of 1928. And in February 28th, he started the all-meat diet. And then he left the hospital on April 20th and continued on the meat diet at home from there. His diet was carefully checked by one of the dietitians, and he came to the metabolic ward for observations and blood studies throughout the 1-year period. So he completed 375 days on an exclusive meat diet, followed after that by 2 periods of 1 week each of a high-fat diet and then a general mixed diet. For Anderson entered the metabolic ward on January 6, 1928 with a preliminary 3-week mixed diet. The meat diet began on January 24th. He was in the metabolic ward study on that meat diet for 90 days until April 22nd, 1928. He re-entered the ward then on January 4th, 1929 for concluding studies. Meat was continued for 3 weeks until January 24th, making a total of 367 days on the all-meat diet. The next 3 weeks after that included 3 periods which he received all-fat diets. Okay, so Stephenson ate approximately 1.79 pounds of meat per day. Anderson ate approximately 1.74 pounds of meat per day. The total protein intake actually wasn't super high. I would consider that a moderate amount of protein of 125 grams. It was more of a high-fat diet, 225 grams. But obviously still good amounts of protein, enough to induce low-grade acidosis, and we'll cover that in a second. But most of the calories came 75 to 80% from fat. Total calories range anywhere from 2,000 to 3,100 calories per day. So the data for the meat periods were obtained from analyses of portions of meat, which duplicated as closely as possible the meat actually eaten. The meat was usually lightly cooked, and the bone marrow was consumed raw. The men took preference to actually boiling meat together with the fluid in which the meat was cooked, and they consumed that fluid as well. They ate some steaks and chops, but these were not the actual most desired portions. They preferred rib cuts, shank, tongue, and liver to the usual steaks. So you could say that this was, somewhat of a higher collagen carnivore diet that also included some organs and a good amount of fat, and a moderate protein. So not super, super high. So there would be a larger acid load on those who are consuming a higher amount of protein than 125 grams per day, which most carnivores are. Most carnivores that I've discussed with are consuming like somewhere between 150 to 200 grams, and then people like Sean Baker are probably consuming like upwards of 300 grams of protein. And the actual Inuit consumed about that. They consume somewhere like 250 to 300 grams of protein. So carrying on, meat was cut from the bone and trimmed before weighing and being served to the two individuals. But in period 7, Stephenson ate meat directly from the bone, which actually gave him some much more calcium. And I'll discuss that in a second, why that's important. The meat used during the first 3 months was actually selected from freshly killed animals. They had been butchered the day before. So this isn't exactly the same as like 2 to 3 week grocery store meat that we would consume for 3 months, but then the remainder of the time it was refrigerated meat from local markets. So the acidity of the urine showed a 2 to 3 fold increase during the meat diet as compared with the acidity of the preliminary period, which we would expect to find if they were eating that. And the findings, they stated, reflects the distinctively acid nature of the diet. So the acidity in the urine is directly reflective of the acidity, the hydrogen ions that are released from the liver upon oxidation of sulfur-containing amino acids, which are high in animal protein. So the reason why your urine is acidic is because you've released an acid load in the body. So a good way of determining if your diet is leading to low-grade acidosis is looking at the pH of the urine. And if your pH is 6 or less, that is a very significant acid load. And I'll cover this in a little bit too. They consumed not a high amount of salt, somewhere between like 1 to 5 grams of salt per day from table salt. So they weren't on a no salt intake, but they weren't on a high salt intake either. They got 1 to 2 liters of liquids from coffee, black tea, meat broths, and water. And did they adhere strictly to the diet? That's the key, right? And so the metabolic wart study, they were under lock and key, and the authors also wrote, we can answer in the affirmative with confidence for 3 reasons that they adhered to the diet. First, the subjects were under close observation during a large part of the intensive studies. Second, in every individual specimen of urine, which was tested during the intervals when they were living at home, acetone bodies were present in amounts so constant that fluctuations in the carb intake were practically ruled out. No albumin in blood cells or casts in the urine were found. And we can basically, there's been studies looking at when you give someone like 180 grams of protein to help like younger individuals that have really good renal reserve, where eating a high amount of animal protein, even for out to a full week, not just like 1 or 2 meals, significantly more than doubles the albumin in the urine, because it leads to a significant hyperfiltration at the kidney level because of the acid load, but also to try to get rid of so much urea when you overconsume protein. They weren't really overconsuming protein in this study, so it makes sense there wouldn't be albumin in the urine because they weren't really eating that high amount of animal protein. But there have been several other studies that have shown in younger individuals that have really good renal reserve, because that means that they can really hyperfilter and they can really boost GFR. We see more than doubling of albumin in the urine. I won't cover those studies in this video, but just know that yes, in younger individuals with good renal reserve that can hyperfilter and significantly increase their GFR, that high animal protein, not 125, it was like 180 grams was given. It was like 2.5 grams per kilogram, more than doubled albumin in the urine. So I still think we need more data on if actually eating high amounts of animal protein can lead to damage to the kidneys, especially in younger individuals that can hyperfilter, and that's called good renal reserve, where there has been several studies showing a significant increase in albumin in the urine just eating animal protein. But I digress. The first test on each subject made at the end of 1 year on the meat diet showed an excretion of urea, which was above the average for normal men on the mixed diets. No evidence of kidney hypertrophy though, so kidneys are looking okay. But the calcium balance was significantly negative. So it was negative for all the periods on the all meat diet. This is Anderson's calcium balances. So for the 117 days that they had calcium balances where they were measuring the intake, the urine, and the feces, and thus the total balance, Anderson lost over 34,000 milligrams of calcium. Now, most of that is going to come from bone because there's only about 10 to maybe 14,000 milligrams of calcium in the body outside of the bone. And so in just the 117 days out of the 370 that they had calcium balances, Anderson lost over 34,000 milligrams. So over the whole course of the study, right, because this is only 4 months worth of calcium balance data, when he was on it for 12 months, so you could basically multiply it by 3, you're looking at like 100,000 milligrams of calcium that would have been lost out of the body. And there's only about 10,000 milligrams that could have come from anywhere else besides bone. But actually it'd be much less than how much is outside of the bone, because you can only lose about 2,000 milligrams at the very most of that 10 to 14,000 before you would die. You basically can't lose very much calcium from other places besides bone, because all you're left with is like smooth muscle and blood. And if blood calcium drops, you'll die very quickly. So you can only lose actually about 2,000 milligrams. So of this 34,000, 32,000 had to have come from bone. And then, like I said, over the course of probably the entire study, Anderson probably lost like 100,000 milligrams of calcium. So this study, in my opinion, proves that calcium is lost from bone, because we physiologically just can't lose more than 2,000 milligrams of calcium out of the body from any other place besides bone. Okay. So this was Stephenson's calcium balances. He had much less calcium balances taken. He only had 40 days worth versus Anderson had 117 days worth. So in period 7, as I had mentioned before, he actually gnawed on bone and got a lot more calcium. So that's why there was so much calcium in the stool. So this underestimated how much he ate here. So I readjusted it. They had said he lost about 15,000 milligrams of calcium. He probably actually only lost like 9,400, but that's still a lot for just 40 days worth of calcium balances. Again, that's basically about how much is, outside of the bone, somewhere like 10 to maybe 14,000. But only 2,000 could be lost from bone. So definitely 7,400 out of that 9,400 would have had to have come from bone. And then again, this is only 40 days worth. He was on the diet for over an entire year. Okay, so negative calcium balances for the year. On average, Anderson lost 295 milligrams per day, and Stephenson lost 237 milligrams of calcium out the body every single day. By month 11 and 12, when they did their calcium balances starting at month 11, Anderson had 3 different balance studies, and Stephenson had 1 out to 12 months. They were still losing somewhere like 175 milligrams of calcium per day. So it wasn't like a slight negative calcium balance. That's a very significant negative calcium balance. So this 1 year, 3-month metabolic ward study essentially proves that a muscle meat carnivore diet does not provide enough calcium because it cannot even keep you in positive balance. So the minimal bar we have on an essential nutrient is that it has to keep you in positive balance. You can't eat a diet that is continually causing you to lose calcium. That is the minimal bar. The minimal bar is to keep you in a positive calcium balance. And this 1 year carnivore study that was a partial metabolic ward study proves that meat does not provide enough calcium, that it is being stripped from bone. And when you look into how the body will adapt when an essential mineral is being lost. So for example, when you go on a low carb diet, sodium starts spilling out the urine, but the body will compensate within 24 hours, increasing ammonium so that the positively charged sodium starts to decrease in the urine and you lose more of a positively charged ammonium to offset the loss, because the body does not want to lose an essential mineral because it will die and perish if it keeps happening. So for sodium, the body, and on a low carb diet, can completely basically shut off those sodium losses after about 7 days. And it starts to compensate within 24 hours. You don't really see any compensation here even after an entire year. You're still losing over 170 milligrams of calcium per day. If the body had a compensatory mechanism to stop the calcium loss, in my opinion, it should be happening well before 1 year. But what happens, and this has been shown in many clinical studies, is bone breakdown markers increase and bone formation markers decrease on a high carnivorous diet, because the hydrogen ions that get released only 70 to 80% get neutralized by the bicarbonate in the blood. And then the rest make their way through the capillaries and acidify the interstitial fluid. And that will activate osteoclasts to break down bone, and that will decrease the osteoblast activity, which is bone building. And many studies in humans looking at high animal protein diets have shown negative calcium balance, an increase in bone breakdown markers like N and C telepeptides, which are collagen from bone, and decreases in osteocalcin, which is a marker of bone building. So they concluded both men had definitely negative calcium balances throughout the periods of meat ingestion. It was also noted that both the calcium excreted in the urine and the total output were greater than the amounts excreted when they were receiving the mixed diets. This may have been due to the acid nature of the diet. That's what they said back in 1928. Okay, I kind of covered where was the calcium being lost from. We have 1 to 1.4 million milligrams of calcium in the body. 99% of that is in bone. So 1% or 10,000 to 14,000 of calcium in our bodies is not in bone. We can only lose about 2,000 of that. And we had said Anderson lost over 34,000 in 4 months, and Stephenson lost about 9,500 in 40 days. So almost all the calcium had to have come from bone. Okay, so this is what I was talking to you about, the interstitial fluid. So basically, the blood, you can't really look at blood pH because the blood will buffer it, and the blood tries to keep pH normal. So the blood is good buffers, hemoglobin and albumin, which can bind hydrogen ions. Interstitial fluid doesn't have that. So very small changes in the interstitial fluid will activate osteoclasts right here, and it will decrease the activity of osteoblasts. So basically, that's really why, that's the mechanism of, okay, where's all this calcium coming from? Because it has to be coming from bone, but why? And so we know that it's coming from the acid load from the animal protein, increasing the acidity in the interstitial fluid. Okay, so here's another metabolic ward study from Chu et al. Titled Effects of Low Calcium and Variable Protein Intakes on Human Calcium Metabolism. This was a 2-month randomized metabolic ward study. They were confined to the human nutrition unit for 60 days. This was 6 healthy male volunteers, 22 to 32 years old. It was 4 15-day dietary periods of different diets. One was essentially a protein-free diet. One was a medium protein diet that was 76.8 grams of protein per day. And then they were also given a high protein diet for 15 days at 153.6 grams. And then there was another 15-day period, which was the moderate protein intake, and they were supplemented with 900 milligrams of calcium. Okay, so all diets were prepared, weighed into containers for individual meals, and frozen until needed. Vitamins and minerals were supplemented. They consumed at least 1 to 2 liters of water and tea, additional demineralized water intake being unrestricted, but the amounts taken were recorded. Food was homogenized using a blend and analyzed for calcium, sodium, potassium, and magnesium. That also happened in the Belleview study. They homogenized the foods, the portions of the foods that were eaten by Anderson and Stephenson, and the food calcium content was directly measured. Same here in this study, in this metabolic ward study. All subjects remained healthy and active throughout the experiment. So where did the protein come from? White turkey provided over 11 ounces for the high protein diet and just under 5 ounces for the medium protein diet. And then ground beef provided 12.5 ounces for the high protein and only 6.4 in the medium. So essentially it was almost 24 ounces of meat in the high protein intake and only 11 ounces of meat in the more moderate protein intake. So it was 1.5 pounds of meat versus 11.3 ounces of meat. So these individuals were in negative calcium balance. So this is another metabolic ward study proving that eating a high animal protein diet does not even put you in positive calcium balance, that it puts you in a significant negative calcium balance. And it gets worse as the protein intake increases. So it was minus 140 per day of negative calcium balance on 76.8 grams per day of protein, which went to minus 222 at 153 grams per day. Very close to the negative calcium balances from the previous metabolic ward study, the Bellevue study. Minus 237 with Stephenson, minus 295 Anderson on average. This study also cites papers of osteoporosis resulting from high protein, low calcium intakes from animals, and I'll cite some other animal studies too showing this as well. Just kind of adding to the metabolic ward studies in humans. This is a third partial metabolic ward study as well. This is Reddy et al. Effects of low carb, high protein diets on acid-base balance, stone forming propensity, and calcium metabolism. This was in 10 healthy subjects. It was a 6-week, very low carb, high protein diet. They went on their usual diet for 2 weeks, which was 91 grams of protein. Then they went on 2 weeks of a very low carb, high protein diet, which was only 19 grams of carbs and 164 grams of protein. And then they went on a maintenance diet further for 4 more weeks, low carb, high protein, 170 grams of protein per day and 33 grams of carbohydrates. All diets were isocaloric and similar in micronutrient composition. The last week of each diet, they were provided all meals, with the last 4 days of each period being in a metabolic ward inpatient setting. So this is a third partial metabolic ward study showing worsening calcium balance on a high animal protein diet, and I'll cover that in a second. Total fluid intake was kept constant. So they were given a multivitamin and give them a lot of calcium. All 3 periods, they consumed well over 800 milligrams of calcium per day, which on a carnivore diet, on all muscle meat carnivore diet, you're only going to get 100 milligrams. So this is 700 milligrams more than what you would get on a carnivore diet, okay? But still, you can see the calcium balance is significantly worsening going on the high animal protein diet. So urinary calcium went from 160 milligrams per day on the usual diet of 91 grams of protein to about 250 milligrams. So the urinary calcium, despite eating less calcium, increased by 90 milligrams per day. So even though on the high animal protein diet, they were eating somewhere between like 60 and 80 milligrams less calcium, they were losing almost 100 milligrams more in the urine, and the calcium balances decreased by 90 to 130 milligrams per day. Again, just another partial metabolic ward study showing that calcium balance worsens, urinary calcium significantly increases due to eating more animal protein. This study suggests that you need at least about 650 milligrams of calcium per day to be in positive calcium balance on a high protein carnivore diet. Also, markers of bone breakdown, bone resorption trended upward, and markers of bone formation, serum osteocalcin, significantly decreased on the high animal protein intake. This is another study. This was in 7 healthy individuals during controlled conditions during increased fixed acid production, achieved either by administering ammonium chloride, we're not going to worry about that, or through an increase in dietary protein intake, which we are going to worry about. When acid production was increased, the subjects were in positive acid balance and negative calcium balance because of increased urinary calcium excretion. This is a 4th study now showing worsening / negative calcium balance on a high animal protein diet. Now, I have covered probably 7 or 8 more in a different video. I'm not going to go through all of those, but this one's interesting because this puts a lot of highlight on the acid load being the cause, because when they gave bicarbonate, the calcium balance went from negative to positive. So their diets contained 908 milligrams of calcium, so they were giving them a lot of calcium. Subjects, so this was a paired balance. Studies were carried out in 7 healthy adult volunteers in the Medical College of Wisconsin Clinical Research Center. We're not going to worry about the ammonium chloride loading. We're going to worry about the individuals, subjects 4, 5, 6, and 7, 2 women, 2 men, were studied on 2 occasions in random order while eating a liquid formula diet in which egg white served as the protein source, and he at a protein intake of either 0.4 grams per kilogram per day, so low protein, or at 1.5 grams per kilogram per day, so high protein. And what you can see here is significantly worsening calcium balances. So patient 4 went from a positive calcium balance to a negative. Patient 6 went from negative to even worse negative, and patient 7 went from a very, very positive calcium balance to a slightly positive calcium balance. So what's interesting, remember I had said they were ingesting over 900 milligrams of calcium. So patient 4 would have needed 952 milligrams of calcium just to remain in positive balance. So they were in negative balance when they ate more protein. So that's a very high amount of calcium intake. You're not going to get that eating just muscle meat. Again, you only get 100, maybe 150 milligrams per day of eating just like 2 pounds of muscle meat per day, not even close to 950. Patient 6 would have needed almost 1,200 milligrams of calcium to remain in positive balance, and patient 7 would have needed almost 800 milligrams of calcium. So on a carnivore diet or high protein intake, you're probably going to need somewhere between anywhere from 650 to 1,200 milligrams of calcium, depending on the person, just to remain in positive calcium balance. And again, you only get about 100 to 150 milligrams eating just muscle meat. Okay, so this study here, let's calcium balance and acid-base status of women. This is where they gave different varying protein intakes in bicarbonate and showed that actually alkalinizing the body reversed the negative calcium balance, and that the high protein diet caused a negative calcium balance. So this was in 6 women aged 38 to 62. This was a 40-day metabolic study to investigate the effects of protein intake and sodium bicarbonate on urinary calcium, net calcium balance, renal net acid excretion, venous blood pH, bicarbonate, etc. So the diet contained 44 grams of protein during the first 16 days and 102 grams of protein during the remaining 24 days. During the last 10 days of the study, 5.85 grams of sodium bicarbonate was ingested concomitantly with a higher protein intake. The increase in protein intake significantly increased urinary calcium and net acid excretion, and the mean net calcium balance became negative. So this is a 4th study showing that throwing someone from positive to negative, the ingestion of sodium bicarbonate alkalinized the urine, and it also alkalinized the body, and reversed the increase in urinary calcium from the higher protein intake, and the mean net calcium balance went from negative to positive. Okay, so it was 40 days in length. This study was a repeated measures design in which each subject received all 3 dietary treatments and acted and served as their own control. And we kind of covered, how long they were on each of these. And here you can see on the 44 grams of protein, they were eating on average 516 milligrams of calcium per day. They were in positive balance, 8 milligrams of calcium. When they increased their dietary protein intake to 102 grams, again, they were consuming the same amount, 515 versus 516, essentially the same amount of calcium per day, and a fairly high amount. They went into significant negative calcium balance. Again, this is sort of highlighting that 650 milligram per day level that's needed kind of at a minimum to remain in positive balance on, and this isn't even that high of an animal protein diet, right? Like 150, 200 grams of animal protein, you're going to need a lot more than 650 milligrams, most likely. But again, what they showed is positive calcium balance on the low protein went to significant negative calcium balance on the higher protein intake. And this was reversed, so this is the higher protein intake when they gave sodium bicarbonate. It went to significantly positive calcium balance, even more so than on the low protein. So this is why I tell people and why I take sodium/potassium bicarbonate with my animal-based meals, because I don't want to be in negative calcium balance. Okay, so people like Bart K will also say the change in the pH and the change in the bicarbonate is meaningless. Well, is that really true? He believes it's meaningless because it doesn't go to the low end of normal. Now, by the way, I can show you many screenshots of carnivores actually with their CO2 levels and bicarbonate levels in the clinically low range. So bicarbonate is 95% of CO2. So if a CO2 is 23, your bicarb is less than 22, which is clinically low. So check your CO2 if you're on a carnivore diet. If it's 23 or less, that's clinically low bicarb. I've seen CO2s 18 to 21 in carnivores. Okay, so I've seen clinically low bicarb and CO2 levels on several carnivores, and actually several prominent carnivores. But in this study, you can see that just going from a bicarb of 25 to slightly below 24 was enough to put them into negative calcium balance, right? So this would be considered a normal level, right? Bicarb is technically not low unless it's less than 22 to 23, depending on what lab. They weren't clinically low, but that was enough to induce negative calcium balance. It was a significant acid load to induce negative calcium balance, and when you alkalinize them, it gave them positive balance. So in my opinion, yes, this is a clinically meaningful drop in bicarb because there's a clinically meaningful change in calcium balance. So I believe Barkay is wrong in his assumption that these changes in acid-base balance are not clinically significant. To me, they are. Let's look at humans too on a highly carnivorous diet. So the Inuit, they've been looked at extensively on bone health. So basically, Inuit that had consumed a traditional Inuit diet for most of their lives, if not all of their lives, were studied in this. Several papers, and I'll cover these here. Measures of bone mineral content were made using radiological methods during the summers of 1968 and 1969, an Inuit from Wainwright, Alaska. And you can see here, what basically 100 children and 33 adults is what they looked at, okay, and what they used. Direct photon absorptiometry was developed, by this university, blah, 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 shown to be accurate and precise within a 1% to 2% error. So they looked at, the Inuit, and I'll show you how I know that they were consuming a traditional Inuit diet too, from some of my publications. So the elderly Eskimos, both male and female, showed a remarkably lower bone mineral content, minus 12% compared to U.S. whites. This decrease would be sufficient to classify most Eskimo women over age 40 as osteoporotic and subject to risk of fracture. This excessive loss of bone could be associated with a highly acid diet of the Eskimo. So that was their preliminary report. Then they published their formal report on the direct photon absorptiometry, was used to measure bone mineral content of forearm bones in Eskimo natives of North Coast Alaska. And I'll kind of show you, the North Coast Alaska regions. The sample consisted of 217 children, 89 adults, 107 elderly over 50. When they say elderly, over 50 years old. Eskimo children had a lower bone mineral density compared to U.S. whites by 5 to 10%, but this was consistent with a little bit smaller body and bone size. Young adult Eskimos of both sexes were similar to whites, but after the age of 40, the Eskimos of both sexes had a deficit of 10 to 15% relative to white standards. Aging bone loss, which occurs in many populations, has an earlier onset and greater intensity in the Eskimos. Okay, nutritional factors of high protein, high nitrogen, high phosphorus, and low calcium may be implicated, but they go on to say it's probably not due to the low calcium because they ate a lot of fish bones. They boiled a whole fish and got actually a lot of calcium that way, and I'll show you that in a second. Okay, so here's the Eskimos that were studied, the Inuit that were studied. These are very isolated regions. Point Hope was studied. Wainwright and Point Barrow is even more isolated than Wainwright. So these are, the northern slopes of Alaska. Now, this was a paper that I published on the Point Hope Inuit. This was from Feldman. This data comes from Feldman. That was published in 1972. Remember that they looked at Inuit from 1968 and 1969. So this was before even this was published. And these were individuals, remember, I'll go over some of the ones that were older, over 50, and looking at 60 and 70-year-olds. So the 60 and 70-year-olds would have been born in the late 1800s from these areas, Point Hope, Wainwright, and Point Barrow. And at Point Hope in 1972, here's how little carb they were ingesting, less than or equal to 10%, with less than 30 grams per day of sugar. Okay, so again, the scans were done prior to this publication, and if they were 60 or 70 years old, those Inuit would have been born in Point Hope in the late 1800s. And even in 1972, they were consuming a very low carb, traditional Inuit diet, is what was said by Feldman. Okay. So 1969 data was published. In 1970, additional subjects were measured in Point Hope and Point Barrow. So they added a bunch of subjects from their preliminary report on this paper here. That's why they had such a larger sample, right? Over 200 children, 89 adults, and 107 elderly, over 50. And what they stated here, during the decade from 40 to 49, the Eskimos had 10% lower values than U.S. whites, and the deficit increased to 14% in the succeeding 2 decades. During the 70s, the Eskimo males were 15% below comparable whites, and females were almost 30% below. Okay, so less bone mineral content in their bones. In whites, it had been shown that a radius shaft bone mineral value of 680 milligrams per centimeter discriminates between normal and osteoporotic females. Interestingly, white females tend to have a plateau in their bone loss at approximately this value during their 70s. Eskimo women reached this state of demineralization during their 60s, a full decade earlier than white females. And the Eskimos showed no evidence of a plateau in bone loss, so that in the 70s, demineralization continued to even greater levels. 60% of Eskimo women over the age of 60 would be classified in the population at risk of fracture by the above criterion, and by age 70, virtually all Eskimo women were in this class. So they also looked at extinct Inuit that went extinct. The Sadler-Muet in 1902 and 1903 went extinct. Essentially, only 5 living members survived that, and then 2 of them died in 1908. But looking at the bones of extinct Sadler-Muet, they had significantly lower bone mineral density and compression fracture. So It states studies on the bones of modern Eskimo population, the Sadler-Inuit Eskimo from Southampton Island at the northern border of Hudson Bay, again, these are the extinct Inuit, have indicated that they had normal bone composition, that the densities of bones, sections, and of whole bones were comparable to those of our white population. However, the older group, over 35, both male and female, so again, it's saying maybe something in the diet takes a while, right, for this to happen. What could it be that low-grade acidosis where it's hitting the older Inuit? Had almost a 10 to 15% lower bone weight and density than young adults. This is in striking concordance with present results of living Eskimos. Interestingly, the studies of MERBs on Sadler-Inuit skeletal pathology have indicated that there was a high incidence of vertebral compression fractures. So not just low bone mineral density, but actually a high rate of vertebral fractures in Inuit, again, that went extinct in 1902. And if they were over 35, that means that they would have been born in at least the late 1860s or earlier. Okay, so very likely these individuals were also consuming a traditional Inuit diet. Recent investigations have indicated the density of long bones were correlated with the number and severity of compression fractures. The extensive aging bone loss in contemporary Eskimos may also be correlated with that pathology. Okay. The most obvious factor in the 2 to 3% higher rate of bone loss in middle-aged Eskimos would be their meat diet. And then these authors also cite studies indicating that young animals develop bone demineralization on meat diets. They also noted that the Eskimo are exposed to sunlight during the summer, and their own storage, supplemented by animal fats, probably accounts for the lack of evidence of any vitamin D deficiency even in their children. Calcium intakes, again, through eating whole fish with the bones, is sufficiently high, 500 to 2,500 milligrams per day, to preclude a deficiency of this mineral even in the presence of poor absorption. Okay, so essentially they're saying the Eskimo weren't deficient in vitamin D or calcium, and that is likely the high animal protein diet. We cannot say for sure. All I'm saying is this plus the numerous metabolic wart studies in humans highly suggest, in my opinion, the metabolic wart studies prove that a high animal protein carnivorous diet does not provide enough calcium and leads to significant calcium loss through bone breakdown. This is just adding evidence to the better evidence that I covered, that the Inuit also, during later in life, had poor bone health, high rates of vertebral compression fractures, which these authors suggested was not due to low calcium or vitamin D, was due to their high acid-promoting diets due to the high amounts of animal protein. So, in my opinion, yes, a all-muscle meat carnivore diet does not provide enough calcium, leads to significantly increases in bone breakdown, causing significant calcium losses from bone, and leads to a clinically meaningful low-grade acidosis, something that I've published several times on in the academic literature.